Hi everyone, welcome to the module 5th on data warehousing concept. In this module, we'll be talking about the basic concepts in a data warehouse, and in the subsequent modules, we'll be talking more detail into the other concepts of data warehouse. So the concepts which we are going to deal today is this. We will be talking about what is normalization. We have been talking about the denormalization, or we have been saying consistently that data warehousing, all the database are denormalized. We'll be talking very briefly about the architecture of data warehouse. We have covered some very preliminary architecture into our first module. We'll be covering more into the architecture, and we'll be talking about different architecture which is supported by different thought processes which are prominent into the data warehousing solutions. We'll be talking about Kimberly and Imam. These are the two architectures or two thought process which are very famous into the data warehousing solution. We'll be talking about certain concepts like staging area. What is a staging area? We'll talk about the modeling, how a data warehouse is being modeled. We'll also try to create a sample data warehouse. Okay. This data warehouse will be basically a sales data warehouse where we'll be talking about creating a fact table, and we'll have a certain dimensions into a sales. It will be basically a retail application. Okay. And how do you create a data warehouse onto a retail application? Then we'll create a dimension table. As I mentioned, we'll be talking about what is dimension table, what are the facts table, okay, and what are the different types of schema which are available into a data warehouse. Okay, we'll talk about star schema, we'll talk about snowflake schema, right? So let's go ahead and start the concept of normalization, right? So why do we need to do a normalization into a database? Okay, and what are the pros and cons of a normalization, right? So as the statement says over here, normalization is basically done with a two main tasks. Okay, so the objective of normalization into any relational database management system is to break down the table into a more decompose as a table into more subtables where you can eliminate the redundancy and the duplicacy. Okay, and the second thing is that you have a data dependency that makes it logically more sense when you are doing this data dependency. Okay, so what does that two statement means? Okay, let's take up an example and then we will see. So if you see this table, okay, let's take up this table. Okay, I have a table. Okay, and in this table I have certain columns. I have a student ID, I have a name, I have an address, and I have a subject. So this is student, say for example Adams might have enrolled for biology subject, and later he might have enrolled for the physics subject also, right? And if you see the address is same, so this is the same student, but he's opting for a different subject. Okay, so initially he might have opted for this subject, and then later he might have decided to go for this. Okay, so now what happens, right? So what is the typical problem with this structure? Okay, so say for example you wanted to update the address for Adam. Okay, so what will happen if Adam has moved from Noida, so he has moved to any other location like Bangalore or Chandigarh? What will happen? The all the rows which are available in this table for Adam, this all rows has to be updated. Okay, so whenever you're doing any operation like update, okay, if you imagine, it will if you know, the locking will happen on the entire table. Okay, it will put a lock, and that lock, during the locking mechanism, you will not be able to do any operations. Okay, neither nor not a select operation also. Okay, so what is the problem with this? If you have to update the address for this student, okay, you have to put a lock on the entire structure, and then all the rows associated with this student has to be updated, right? So that is very very difficult, and that would take a lot of logs on your on an entire database table. Okay, and that is not convenient. Okay, the second problem. So what would be the second problem? So just imagine a case. Okay, say for example I have a student, okay, who has not opted for any subject. Okay, what will happen in that case? I still have to maintain his records, and what will happen in subjects, if he has not opted, I need to insert a null value. Okay, what if I have defined this as a not null column? Okay, what will happen in that? Even if I have not defined is a null column and most of the students are not opted for any subject, I still need to make an entry into this table. Okay, and that is where I will be figuring out whether I have missed to insert the subject, or that student has still not opted for a subject, right? So there is an anomaly which will be occurring. What would be the third issue with this table? Okay, the third issue would be, say for example I have only one record for Alex. Okay, and I have a single record for Stuart, because they both have opted for only a single subject, right? Not like 401. So if a student is de-enrolling from maths, okay, and I wanted to delete this entry, and what if I delete this record? Okay, in order to delete this entry, I need to delete this record. So what will happen? The entire record for Alex will be lost. Okay, and you will not be able to find Alex, who is Alex, and what are the different what is his address, and so on and so forth. You have to maintain and separate, you have to insert a new record for that, right? So these are the different different problem statement that you will face when you have this type of structure. Okay, so let's quickly check a table. So I've covered this anomaly structure and all. Okay, let me quickly show you the table which is not in a normal form. Okay, so I have a query. Okay, I have a customer table. Okay, and let me open my SQL Server Management Studio. Okay, so I have a database where I have a table called, I have created a sales warehouse, and within that I have created a table. Okay, and this customer table is not in any normal form. Okay, so let's see what data it contains. So if you see this, I have a table where I am putting the ID. I am creating a name, that Kumar Wisdom, and his age, his address, and the course what he has ordered. Okay, so if I have a different entry, okay, in this case I have a same ID for this guy. Okay, so if there is another guy which is called 101, okay, ideally it has to be 101, 2, 3, and 4. Okay, and the same name and the same address and so on. If the Wisdom, Kumar Wisdom, has changed his address from Bangalore to Hyderabad, what will happen? You have to put a lock on this table, and you have to update the entire record set. Okay, the second is, if say for example I have another record over here, and say for example I have a record for Ashish. Okay, and he has taken a Hadoop course. Okay, and that is the only course he has taken, and for some reason I don't want, or he is not willing to continue with the Hadoop course. What will happen? I will have to delete this record from the customer table, and the entire information for the Ashish will be deleted, right? So this is the typical database which is not in a normal form. Okay, so we have a query available here. You can see the queries. Okay, and what courses he has ordered, what is his address, and the age and the phone number. Okay, right. So since this table is not in a normal form, right, so the very first thing I would like to now see is how I can make this table at least into the first normal form. Okay, and what is the first normal form? Okay, that we will quickly see now. Okay, so in a first normal form, okay, what the first normal says, that no two rows of the data must contain the repeating group of information. Okay, 1 second guys. Okay, so let's see how do I convert this into a first normal form. So first normal form, as I said, it 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 has a two properties. First thing, it need to have a primary key which is not available since this table is not in a first normal form. Also, it says you should not have a repeated information or multiple information in the same column. Okay. So let's see how do I convert this into a first normal form. Okay. So let me quickly show you the data. Now I convert my data into the first normal form. Okay, and now if you see, I have ID 100. Okay, and I can insert multiple records, okay, with a different ID, right? And that is where the first normal form comes into the picture. Okay, and I need to define this ID as a primary key. Okay, I need to include this primary key ID into my table, and as a PKID, and I can include from 101 to 104. I need to have a 4 different records. Okay, so that is one way of looking into it. The another way of looking into it is this. Okay, if I have a information something like this, which I am showing you over here, this is a student table. Okay, this table is having an information, okay, and which is saying for Adam he has taken 2 subjects, so it is having biology and maths. Okay, and for Alex it is a math, and for Stuart it is a again a math. So this is not in a first normal form. Okay, so what, how do I convert this into a first normal form? If I have to convert this into a first normal form, I have to make a 2 separate rows for Adam. Okay, so the set of rows which uniquely identify this record. Okay, so this is how a set of all the data will uniquely identify. If I have to say student, age and subject, so then I will say this is my row. Okay, which was not the case over here, because even if I say Adam age 15 and biology, it will fetch me this row. And even if I say Adam age and subject as math, it will again fetch me the same row. Okay, and that is not what we want in the first normal form. So in order, okay, so in order to have this into a first normal form, what it says, no 2 rows of a data must contain repeating group of information. That is, each set of column must have a unique value, right? So set of a column, when we're talking about, it should have a unique value such that the multiple columns cannot be used to fetch the same row. If I'm using, you cannot use the multiple column to fetch the same row. Okay, so even you can convert this into this. Okay, like this. So when I say Adam age and age is 15 and subject is this, then I'll fetch up this row. Okay, the second example is this, where it is not in a normal form. Okay, in a first normal form. Why it is not in a first normal form? The reason is this. Okay, if I say name and state, and I have a country and I have a phone number over here, if I include this, these are multiple columns over here. In case I'm passing all the 4 parameters of the phone number also, I am fetching up this record. Even if I'm passing with these 3 parameters and the phone number, I'm still getting the same record set. Okay, I really don't want to have it, and that is where I have to break down this columns into multiple rows, and that is where I can differentiate between the multiple phone numbers. Okay, so I cannot have the phone numbers, because since it is having a 3 phone number, I cannot put everything on a single column like a phone. Okay, so I have to make a separate row for that. Right? So this is the first normal form. Okay, and the previous thing we have converted into the first normal form, customer table, like this. Okay, then what is the second normal form? Okay, second normal form says, okay, that there should not be any partial dependency. Okay, and when we are talking about partial dependency, then we can say if student and age, okay, if you take this example over here, student and age is dependent, but age and subject is not dependent, right? So there is a partial dependency, and student and subject is dependent, but age and subjects are not dependent. So Adam has taken biology and Adam's age is 15, but 15 and biology are not dependent, right? So this age and subject is not, dependency is not there. So that is where you need to remove all the partial dependency into a separate set of a table. That is what a conversion from the first normal form to second normal form. The second criteria is like the column should be in a first normal form, okay, or the table should be in a first normal form, right? So if you see this, we have broken this table and now it is into student and age into another one table, and a student and subject into another table, right? So we have to make two separate tables for that. Okay, so this is the second normal form. If you take example, the second example which I was talking with the phone number, okay, I have to divide because John's phone number is correct, but his state and country is not dependent, right? So because sorry, the state and phone number is not dependency, so I need to put this into a separate table. Similarly, country and phone number is not dependent. So what I can do, I can put this name and state and country, okay, or I can just remove the country. I can have John is belonging to this state, and then I can create a phone number dependency where I have this John ID is 1 and is having this phone number, right? So and then again I can convert this state to country into another normal form. Okay, so there will be another set of table in a second normal form, right? So this is the second example. Okay, if you have to see my customer table which is in a second normal form, I just have to select this and I will have only those two columns. I will just have the customer ID and the customer name, and I will eliminate. Okay, one second guys. Okay, so customer ID and name. Okay, so I think I should have. Okay, so let's continue with the third normal form. In the third normal form, what is that? What we need to take care is that the very first thing is that you need to take care or that it is in second normal form, and there should not be any transitive dependency. What do you mean by transitive dependency? It means state is dependent on country, right? So if you see the above example, okay, so I have a student ID, name, and so on and so forth. If you see the city and state, city and zip, they have a dependency over the on each other, right? So all whenever you have a dependency that city belongs to state, okay, and the zip belongs to a particular city, right? So then it is a transitive dependency and it has to be moved to a separate table. Okay, so that is what we have done. We have put the date of birth and the zip in one table, and the address table is having a zip and so on and so forth, right? Okay, so this is my table where I'm saying this is the John and this from this country and this is the state. Okay, state and the country dependency. Okay, I need to divide this table into multiple tables. Okay, where I have a student detail. Okay, I put it like this. Then I will have a address table where which will have this type of data. Okay, so I need to literally move these two columns, state and country, into another table. Okay, and I can have one address ID created which I can refer it to this table. Okay, so we have like tried to cover the basics, very basics of normalization and the different kinds of normalization, the first normal form, second normal form, and the third normal form. Okay, it is very very important to understand it because in normally in a OLTP system where you will see a lot of interdependency into the tables, because that is how the solution is being designed, okay, into a OLTP system. But if you are, and that is the reason in a typical OLTP system you have multiple tables, okay, you have very large huge number of tables because of this normalization structure. Okay, whereas in a data warehouse you would really would not like to have this multiple tables. You would not like to have divide your table or divide your data across the multiple table. Okay, the reason being the performance impact, which is in a data warehouse. Okay, if you have a multiple table, it will impact your performance of your data warehouse. That is the reason we go ahead with the denormalized structure, right? So if you take our very first example of a customer table, this is my customer table. So if you see this customer table is highly denormalized, and that is what people would be keeping it into when they are dealing with the data warehousing solution. Okay, So let's continue with another concept, or data warehouse typical architecture, right? So I spoke very briefly about the data warehouse, like it follows uh, a denormalized structure in the database. But what is like typical the architecture of a data warehouse, right? So you have multiple source systems and the source data is coming. So this data is coming from multiple sources, if you see this, and this the data which is coming, you can have this as your first system, this can be your second system, and this can be your third system, right? So we have covered very briefly about all of this, that this can be a shares application, this can be loans application, and so on and so forth. So through the ETL process it will move into the data warehouse, and from the data warehouse again you can move to into a certain data marts. Data marts are subset of data warehouse, where you can move a subset of a data through your ETL process so that it can be viewed by a set of business user, or you can directly move from data warehouse to the cubes. We will talk about the cubes, but having said that, cube is a pre-aggregated data, okay, and you can hook on to the reporting solution on the cube, okay, and that is how you can show your reports, as well as you have a certain data mining which you can do with certain tools over here, okay. Right. So what are the different components into our architecture? The various components is, these are my operational systems. Okay. That is what we are talking about. Then the ETL system. This is my ETL system. Okay. Then this is my warehouse, and this is the presentation layer. Okay. And this are all are my presentation, and this is my business intelligence and reporting layer. Okay. Fine. So operational data source, that is what the various system what we're talking about, the customer application, the loan application, and the shares application, whatever the online transaction processing system what we're talking about. Okay. So this is a very explanation about the architecture, the source systems, and it says what ETL exactly does. ETL will transform your data. So in this layer, there will be a certain transformation. There will be data transformation, there will be a data quality check, okay, and there would be certain normalization or the optimization which will be done, okay, and then it will be moved into a warehouse, okay, that is like enterprise data warehouse, and from there the business application will take care, okay. And in this, the dimensional model is basically a OLAP cube, okay, as I mentioned, okay. And one more thing is that very important is, like, when I'm talking about dimension, it is very important to understand what is the dimension and the fact, okay. So we'll cover that dimensions and the facts in some time, okay. ETL stands for extract, transformation, and the loading, okay. So extraction is just taking a data from the source system and copying the data. It's like more, you can copy the data from here and put it into a certain staging area, and after the data is copied into the staging area, you would like to do certain transformation, and that transformation can be cleaning, okay. And when I say a cleaning task, it can be a spell correct, or it can be a domain conflict check, or it can be a missing element, or it can be, so if you have a null, how do you want to show it as, okay, or any standard format, right? So when, because if you have a data coming from multiple sources, if from in this source it is coming as USA, and from this source it is coming as United States, both ideally remains the same, right, or both are same. So you have to tell that, you have to understand the different master data which is coming from different sources, they both are on the same, okay, they both are same, okay. And then finally the loading happens once you do a cleaning of a task and cleaning of a data, you have to load it into a data warehouse, right. And presentation layer is more where you do these are my cubes and the data mart, where you have store your data, and then that data can be used for your reporting application, okay. So there are two types of architecture: independent data mart architecture. Okay, so this architecture, what will happen if you have a multiple source system? What So one of the challenges with this system, with the data warehousing solution, is this. Okay, if you okay, so if you have a multiple application, say for example you have a HR application, okay, you you have a finance application, and you have a sales application, right? So ideally, what would be the best thing? You wanted to see or visualize your data, combining all the data from different systems, and show a integrated view of a data. That is called an enterprise data warehouse, right? So why it is called enterprise? Across the enterprise, you are pulling on the data and then trying to show the data. But sometimes it might happen that if you are trying to pull it across the enterprise, you would not really like to talk to multiple customers because it might impact their existing reporting and all. Okay, so they go with a very approach which is more convenient to them, and then they starts with the approach where they can design the data mart. Okay, so I have my first department and I would need a data, okay, whatever is required, and I just need a two sources. I will not go for all the three sources, right? So I make a data mart coming from these two sources. Okay, data coming from these two sources, and I have a very limited view of my data, and I would like to show it to my limited set of user. Though this will not be useful for all the user because it's not across the enterprise, right? But you still like to visualize this data based on the department specific customers. Okay, again then you have a different set of data mart created. Okay, and this data mart you would like to do it with all the different source system. Okay, and then you can visualize this, you visualize this data based on all the data coming from multiple sources, right? So if you see this, this is more like an enterprise data warehouse where you have data coming from all the different sources. But this two, okay, which I'm highlighting now, okay, this and this are more like a data, like a limited view or a partial view of a data across the enterprise, and that is where data mart type of architecture is called. And your users on this two type of reporting application would be a limited set of users. Okay. So what is the drawback of this? Drawback of this is you would not have a complete view of data across the organization. Okay. So there is some more theory which I will try to cover very fast. Then there is a Imam architecture, who is one of the thought leaders in the ETL design system. Okay, and his architecture says that you have to design across the enterprise, get all the data across the enterprise, and then make a data mart. Okay, which can be visualized by a certain set of people, right? So data mart for HR will be visualized by HR, and data mart for finance application can be viewed across by the finance application guy, right? So what is the dimensional modeling? So dimensional modeling is the modeling which is very prevalent into a data warehousing solution. So in a dimensional modeling, we have a different dimensions. Dimensions are nothing but the context in which you wanted to see the data. Okay. So before we come to dimensional modeling and facts and schemas and all, okay. So let us quickly jump into a scenario. Okay. So this scenario I wanted to cover, and I have created a certain tables and structure so that it is convenient for you to understand the data warehouse. Okay, in a typical data warehouse, okay, what will happen? Say for example, I was the we'll build upon this solution which we talked about in the first video. So I have an application over here. Okay, I have a sales application. As I said, this is my point of sales, and I'll have multiple data in my point of sales, that what item I have bought, what is the quantity, and what is the total cost for the multiple items which I have uh, bought in this. Okay, bought from a certain store. Okay, so all this data, when I have to integrate and see across a different location, like Ahmedabad and Gujarat and so on and so forth. Okay, so what will happen? You would basically like to have view your data across multiple contexts. Okay, So what are those contexts? Let us quickly see that. Okay. So typically the architecture would be you would like to see your data based on the date dimension. So I wanted to see on January, first week of January, how what all what was my total sales. Okay. Similarly, across the product, if I have an n number of product, okay, what is my sales only for my washing machine or only for my washing powder? Okay. Similarly, for the customer, if the customer is from Ahmedabad, all the customer sales from the Ahmedabad location. Okay, and similarly, I will have a store ID. So, store located in Ahmedabad on a certain area. What is my total sale? Okay. Similarly, by the salesperson ID, if I have to see, then I will have a salesperson name, and then I'll make it as a separate context, as a separate dimension table, and I will try to see my data across that. Okay, and then finally I might have this is my date dimension. Similarly, I have a time dimensions, and time is more if I have to see the data on an hourly basis. On a Wednesday between 11 a.m. to 11:30 a.m. what was my sale. So that kind of time related data cannot be accommodated into the time dimension. Otherwise the size of the table would become very huge. We will see that. Okay, so let's see what is my product dimension table and how does it looks like. Okay, so this is my product dimension table. Okay, the queries are all with you, so don't worry guys. Okay, I will try to show you the queries over here. Okay, so this is my customer. I need to create my warehouse, and then I'll start creating my dimension table. Okay, and I'll start inserting certain data into my dimension table. So very first thing is my customer table. I have my customer ID. Okay, I have my customer name and what is my gender ID and so on and so forth. Right, and this is alt ID, which we can ignore it. Okay, so as of now, I'm just saying that. Okay. So I'm inserting certain data into my customer table. Let's see what data I have into my customer table. If you see this, I have, okay, so this is my customer table. It is very important to see that the nomenclature of a table into data warehouse would be something like this. If you have a dimension table, it will look dim customer, and if it is a fact table, if you see, it will be fact table. Okay, so we will be only dealing with this tables. Okay, so rest of the tables which we are not considering, these are a separate set of table which is not belonging to dimensions and fact. Okay, so the fact table nomenclature will start with fact, and dimension table will start with a dimension. So I have a 5 different customer, and this customers, this is the gender, male, female, and so on and so forth, right? So this is my very first table into my data warehouse. Now the second table is obviously the product table. What I wanted to hold in the product table is all the product items, right? So I have a product called wheat, okay, and then I have a rice, and what is the product cost, actual cost or the cost price, and then what is my selling price for that product. Okay, and then I have a Nirma soap, and I have a Ariel washing powder, and I have a sunflower oil, and so on and so forth. So you as you see, there are multiple products and there is a rate associated with each of the product. So that is my second dimension uh, in my data warehouse, right? The third dimension is the stores, right? Since I have a multiple stores, right? So I would like to create a store because I might have some stores available in Ahmedabad. I might have some stores available in Gujarat, in Calcutta. I might have some stores available in Bangalore. Okay, and I might have multiple stores in the same location, right? So very important to see that I have one store which is located in this Sirangi. One is in Maninagar and one is in SP Ring Road, right? All in the same Ahmedabad city, right? So this is my another dimension table because I would like to see, say for example, I wanted to see my sale only on Maninagar. Okay, what happened on a certain date? Maybe there is a riot or maybe there is a chaos. So what is the total sale which happened? Okay, and then I can figure out what is the reason behind it. Why people didn't go to this store on so and so date? Why suddenly the sale was very down on this rate? on this date. Okay, maybe as the root cause can be a riots or something else, right? Then I have another table called dim salesperson, right? So typically you would like to give incentive based on the salesperson, right? So this salesperson is Ashish and he belongs to the store ID, which I'm saying the store ID 1. So it is on a ring road. Okay. And the store ID 2. So I have a two salesperson, Ashish and Ketan. And similarly for the different store ID, I have a different set of customers, different set of salesperson.